Hi everyone, we have 1 hour for today's recitation, so let's start with our first questions. We are going to solve the homework questions today, so it's not will be so hard. We will do it easily. Let's start with the first one. Okay, I have a little remark for you. Let's think about the return to scale. Okay, what is the constant return to scale? You can think like that. We have a production function, and we have inputs and outputs of that production function, of course. If we increase the same a little bit, if we increase the inputs a little bit, and if we observe that our outputs also increase with the same percentage, then we can argue that our output production function is a constant return to scale. I mean, you can think like that. For example, we have this production function, okay, and we just increase our labor and capital with multiply by 2, and then we will observe that our output will also increase by the same percentage. It's going to be double. Then we can argue that this is constant return to scale. What about the increasing return to scale? We have a production function. Think that this f function shows our production. And then we have labor and capital as an input. If we increase the labor and capital, and if we double them, then if we argue that our output will be more than the double of the first function, initial version, then this is increasing return to scale. What about the decreasing return to scale? It is the opposite version of the second part. Again, we have a production function, and if we double the labor and capital, we will observe that our output will be less than the double of the initial output level. Then we can argue that this is decreasing return to scale. So that's a small remark for our questions. Let's start with the first one. You already solved this. Assume that we have a firm. We have 2 different technologies, A and B. The first one, this one shows the output level for the technology A. This is the output function. And let's assume that we represent it with the minimization. And then we also have for technology B also. This one for the technology B, it shows our output level. It's again the minimization. And show that both technologies have constant return to scale. What we should do, first of all, let's start with writing our information that we can derive from the questions. Okay? So what we have technology A and technology B, and let's assume that we doubled our capital and labor by multiply with A. Let's assume that A shows a constant. Okay, we increase our input, and then what we can argue that then output will be the minimization of the 2AK and AL. Okay, I use this function. I just plug AK for this part, okay, and AL for the second part, for the labor. And I can argue that I get this function, okay, this representation. What can I argue that if it is our output level, it shows out our output function, then it's going to be same with our initial level, our initial output representation of and we are going to multiply this representation with the constant a, okay? So if it is the case, then remember from the first section, this is constant return to scale, okay? We increase our input by a, and then we argue that our output level will be also increased by a. So therefore, it is our output function with the constant return to scale, okay? If you do the same thing for the B part, okay, again, increase the inputs by A, and then we can argue that our output will be represented by this function, minimization of the AK and 2AL, and this function should be equal to minimization of K and 2L by A, by multiply by A, okay? So we again get the same idea. Therefore, B has constant return to scale. So that's the easy one. Just increase by A, increase the inputs, and then observe the outputs, and then argue that these outputs will be the same with our initial output multiplied by the same constant A. Then this is constant return to scale. Okay? Let's go on. I know that professor also solved this question, so this is the simple one. Let's go on with the second one. Let's assume that Don Garcia needs at least 24 units of vitamin A per day. Okay? I assume that we have two different pills. One of them is the green pills, and it provides 4 units of vitamin A. And we also have red pills, and it's going to provide 1 unit of vitamin A. And we also know that our costs for the green pills are, our prices for the green pills and the red pills, and price of green pills is $3.5, assume that, and red pills are $1 for each. How many of each kind of pill should he take to minimize his cost? And our aim is the minimization of the cost. We want to minimize our cost. Okay, let's try to find out information from the questions. We need 24 units of vitamin A. We know that from the questions. And we know that our green pills give us 4 units of vitamin A, and red pills give us 1 unit of vitamin A. We also know the prices of these vitamins. What is our aim? Define our aim. We need to minimize our cost to get 24 units of vitamin A. Let's start with the right total cost function. Okay, I'm going to write this cost function as a function of quantity and price. We have a quantity of green peas and price of green peas. And I know that price of green peas are $3.5. And I know that price of red peas will be $1. Okay. So I just formalize this information and plug them into the total cost function. And then I have constraint function, or you can argue that it's a kind of production function. I know that if I consume this amount of quantity of green peas, I'm going to derive vitamin A from this amount as a multiply by 4 of them. Okay? If I just assume that if I consume 1 unit of green pill, I'm going to get 4 units of vitamin A. So you can formalize it like that. And also, if you consume 1 unit of red pill, you are going to derive 1 unit of vitamin A. So you can also write it like that, formalize it like that. And what I need for these questions, I know that Don Garcia needs 24 units of vitamin A. So we have a kind of level, restricted level for the production function, and it should be equal to 24. Okay? So this is just a summarizing of the questions. I'm going to use the same tool for every question. So it's going to we are going to solve the problem easier. Let's go on. We need to remember some definitions in this part. We need to remember isocost curves, isocost lines, and isoquant curves. Okay, you can argue that this part shows the isoquant. It is not the same for our questions. I just want you to remember the definition, remark the definition. So this is not our exact line for these questions, but assume that this is the isoquant line and this is the isocost line. If you want to minimize the cost, then you need to find out this point, okay? And this point shows the level that marginal rate of technology substitutes equal to slope of this isocost line, okay? So this part shows the isocost line, and if you take the slope of this line, and if you take the slope of this curve in this point, in point X, you need to equalize them, and then you can find out the minimization of the problem. Okay? What it says, we need tangency rule to find out minimization. Okay? We need to pick the bundle of inputs where the desired isoquant is tangent to isocost line. Okay? So that's all. We are going to use the same idea for these questions, but we are going to draw another graph to represent our information. Let's go on. I have one more remark for this part. Let's think about the marginal rate of technical substitution. This is the number of extra units of one input needed to replace one unit of another input that enables a film to keep the amount of output it produces constant marginal rate of technical substitution. How can we formalize this level? It is the change in capital with respect to change in labor. So you can argue that marginal rate of technical substitute is equal to negative version of marginal product of labor divided by marginal product of capital. I assume that you already know the definition of marginal product labor and marginal product of capital. We just use this information to find out marginal rate of technical substitute. That's all. Let's think about our questions. What we are looking for? We are looking for the minimum isocost level which intersects or tangent to isoquant line when the level is 24. We can argue that our isoquant line should be equal to 24 because we know this information from the questions. So some way to find out the slope of isocost line. Okay, I just draw this line. This is our isocost line. So I know that the total cost curve, total cost equation from this part. Okay, this is our total cost equation, this part. Let's assume that you didn't consume or you didn't use any green pill. Then you can argue that your total cost should be equal to quantity of red pill because the price of the red pill is equal to 1. On the other hand, if you just consume a quantity of green pills, your maximum quantity should be equal to total cost divided by $3.5. So this is the intersection point with the y-axis. Let's check from there. Okay, this part shows total cost divided by $3.5 for the green piece. And this part shows total cost. Okay, since the price of the red pill equal to 1, we can argue that our isocost line intersect with the x-axis at the level total cost. And it's going to intersect with the green axis at the level that total cost divided by 3.5, which is equal to 2 multiplied by total cost divided by 7, this amount. So if you find out the slope of this line, you can argue that it is equal to negative version of 2 divided by 7. I just take the slope of this line, okay, this line, okay, it is equal to this level divided by this level. So it's equal to 2 divided by 7. So let's go on. As a second step, we need to find out slope of isocont, which is equal to marginal rate of technical substitute. And I know that it is equal to marginal product of red divided by marginal product of green. Marginal product of red is equal to 1. How can I find it? Think about the production function. If you take the partial derivative of this function with respect to both quantity of green and quantity of red separately, you can find out that marginal product of red should be equal to 1 and marginal product of green should be equal to 4. So I just plug this information for this part, use this part. Then it is equal to minus 1 divided by 4. Okay. Once we know, we find out slope of isocont line and isocont line. And we know that slope of isocont line, negative version of this amount, and minus 1 divided by 4, bigger than the minus 2 divided by 7. Therefore, we can argue that we have not a tangent point, because if you have a tangent point, then these amounts should be equal to each other, but it is not possible in this case. Therefore, we can argue that solution should be on the corner. Solution should be on this corner or this corner. So we need to check the corners and we need to find out the corners level. We know that this part is equal to 0.6. Okay, how can I find out this? Think about this part. If the quantity of red is equal to 0, then quantity of green should be equal to 6. Therefore, first corner should be show the level where green is equal to 6 and red is equal to 0. Think about the second corner. Assume that this part is 0, quantity of green is 0. Then quantity of red should be equal to 24 from this equation. So I can argue that we have two corners, 0.0 and 6, 24 and 0. Check from the first part, check from the 0 and 6, and try to find out the total cost. We know that price of green peas is 3.5 and quantity of green peas is equal to 6. And we know that quantity of red peel equal to 0. Then this formula should be equal to 21. This is our total cost for the point 0 and 6. What about the 24 and 0? If you also find out the total cost for this point, for this bundle, you can argue that it is equal to 24. Since the 21 less than the 24, then we can argue that our solution is equal to bundle where red pill equal to 0 and green pill equal to 6. Okay. This shows the quantity of red pill and quantity of green pill that our consumer or our producers going to use to find out the minimization. Okay, that's all. Let's go on. If you don't have any questions, I'm going to go on with this third one. Suppose output is produced according to production function. We again have a production function. We have three different input level. We have materials, capitals, and labor. And it asks us that, does this production function exhibit decreasing, increasing, or constant return to scale? Again, I have the production function. I wrote it from the question. And I try to find out the type of return to scale. And how can I find out this information? How can I find out the solution? Again, I can take a constant, assume that I'm going to increase our inputs by constant A. I'm going to use A times M, A times K, and A times L as an input. And now I need to observe the output levels. If you use the A times M as an input, A times K and A times L as an input, and if you plug these inputs into the production function, into the this function, you can find out that our output level should be equal to A power by 3 divided by 2 multiple MKL power by 0.5. So we know that this part, okay, this part is equal to our initial output level. I know that from here, this is exactly the same level. So I can argue that if I use this level as an input, I'm going to find out output level as A power 3 divided by 2 times our initial output level. Okay, since this level is higher than the A times initial output level, we can argue that we have increasing return to scale. And I assume that this A is a positive number, okay? It's a positive constant. So since this part is higher than the A, then I can argue that this is increasing return to scale. That's all. I use the same argument. Let's go on with the fourth one. Suppose a firm's average cost curve is described by the equation average cost is equal to this amount of level. At what output level does the marginal cost curve cross the average cost curve? We need to find out a few remarks. We know that total cost, it is equal to sum of variable and fixed cost, and we can formalize total cost like that. An average cost is C divided by output produced. So it is C divided by quantity of output produced, and therefore it is equal to this representation. And what about the marginal cost? This is the amount by which a firm's cost changes if it produces more units of output. So you can formalize marginal cost as a partial derivative of the cost function with respect to output level, output quantity. And we know that from our lessons, marginal cost intersects with average variable cost and average cost at its minimum points, as their minimum points. So this is the simple remark. Let's use this information and for our questions. We need to find out Q level, which minimizes our average cost. And we know that if you want to find out the minimization, you need to find out the partial derivative of the average cost with respect to quantity. If you take the partial derivative of this amount, this equation, you will find out that this is equal to 4Q minus 16. And if you solve this equation, it's going to be equal to 4. So our output level should be equal to 4 to minimize average cost level. Then we can argue that marginal cost curve intersect with average cost curve at point 4. Okay, if the quantity of output will be higher than the 4, then our marginal cost curve is above average cost curve, and it is not the minimization of the problem. As a second way, you can find out the total cost curve because you already know the average cost curve. Then calculate the marginal cost curve. And as a third step, calculate the Q when marginal cost curve equal to average cost curve. If you do this way, if you use this way, you are going to find out the same amount of level as an output level. Okay, it's going to be the same. So that's all. Let's go with the, if you don't have any questions, I'm going with the fifth one. If input prices wage equal to 4 and rent equal to 1, and if we have this production function, what is the least cost input combination required to produce 40 units of output? What we know, I know the input prices, wage and rent, and I have the production function. And as a first step, let's write total cost function as an equation of the wage, labor, rent, and capital. This is the formalization of the total cost. And then specify the problem. We want to find out the mean version of this amount, this total cost, subject to this production level. Okay, so it's going to be our constraint for this problem. And we need to know the definition of the isocost line. It is summarize all combination of inputs that require the same total expenditure. So I know that we have this total cost, and this total if we take the a constant, we find out a constant level for this total cost is going to show an isocost line. We know this from the definition. And recognize that in the question, it asks us that to produce 40 amount of level. So it is a fixed level. So it's going to fixed level isoquant line because this is the fixed level. And we need to find out the minimization. Again, use the tangency rule. Pick the bundle when isoquant line tangent to isocost line. So to find out the tangency, we need to find out the slope of the isocost line and isoquant line. Okay, we know that isocost line equal to negative version of wage divided by rent. We know that from our lessons. And we know that wage is equal to 4 when rent is equal to 1. Therefore, this amount, this slope should be equal to -4. And then find out the isoquant line. It is the marginal rate of technical substitute. And I know that this amount is equal to negative version of the marginal product of labor divided by marginal product of capital. Marginal product of labor equal to partial derivative of the output function divided by labor partial derivative of the output function with respect to labor. If you apply this rule to our question, you will find out that this amount should be our marginal product of labor. And if we use the same idea to find out the marginal product of capital, which is equal to partial derivative of quantity function, output function, with respect to K, then you will find out that it is equal to this amount, and this shows marginal product of capital. If you find out the slope of isoquant curve, which is equal to negative version of marginal product of labor divided by marginal product of capital, you can just plug these amounts into the equation and find out that this slope is equal to minus k divided by L. As a sixth step, we need to find tangent points. And to find out this point, we need to equalize marginal rate of technical substitute and slope of the isoquant line. I know that marginal rate of technical substitute equal to negative version of k divided by L. I know that from this part. And I know that slope of isoquant line equal to -4. If you use this calculation, if you do this calculation, you will find out that K should be equal to 4 times L. Okay? We are going to use this information now. We want to find out a specific level for isoquant level when it is equal to 40. when this amount equal to 40 and K equal to 4 times L, we will solve this problem. Just plug this information, K equal to 4 times L, into this production function. Since the K equal to 4 times L, and if you solve this problem, this equation, you will find out that A times L is equal to 40, and then L should be equal to 5. Okay? And if you plug L into the equation 6, into this part, you will find out that K should be 4 times 5, and therefore it should be equal to 20. Okay? So as a nice step, calculate total cost line, where total cost equal to wage times L plus rent times K. Since I know that L should be equal to 5 and K should be equal to 20, if you solve this equation, this total cost equation, you will find out that this should be equal to 40. Okay? I know that because what I did in this step, I showed that my calculation and the bundle that I can derive for the labor and capital is true, because when I plug this information into the total cost function, I'm going to find out the same output level, 40, which is given in the question. So it shows that our calculations are true. Therefore, we can argue that the bundle, which is minimize the cost function, should be equal to 5 for the labor and 20 for the capital. I wrong. I wrote wrong for this part. This should be L and K, not K and L. Okay. As a B section, suppose instead that capital was fixed at 16 units, what would be the implication for labor usage and the total cost? Again, we have the same amount for the production. We are going to produce 40 units, but we are going to produce this unit when the capital is equal to 16. And we are going to find out the labor and the total cost. When this amount equal to 40 and capital equal to 16, if I plug this information into the production function and leave alone the L, I'm going to find out that L should be equal to 6.25. And if L 6.25 and K equal to 16, I can plug this information into the total cost function, and I find out that total cost should be equal to 41. Okay? I just derive the L from the output function and then plug the information into the total cost function to find out total cost for this level, for this bundle. That's all. Okay? If you have any question, you can write me. I'm going to check them also. Let's go with the 6 questions. Okay, this one, I know that professor also solved this one, but let's do this one more time. Everyone wants to go into the donuts business, and for $500 per month, he can rent a bakery complete with all the equipment he needs to make a dozen different kinds of donuts. And assume that capital should be equal to 1, where rent equal to $500. He must pay unionized donut bakers a monthly salary, which is equal to $400. And he have a production function, which is equal to Q, which represents the Q as a 5 times K and L. And Q shows the tons of donuts. In the A section, it asks us that in the short run, when the capital is fixed at the level of 1, what is the marginal product of labor? Okay, what we know from the questions. I suggest you to do the same ideology when you try to solve the questions. Just summarize the information that you know. We have done business, we have rent information and wage information, and we have not the production function. What we know for the A section, we know that capital should be equal to 1, and it asks us that marginal product of labor. Then try to write some formula that you are going to use for to solve the questions. Marginal product of labor is equal to partial derivative of production function with respect to L, with respect to labor. If you take the partial derivative of this with respect to L, you will find out that this is equal to 5 times K. And we know that K should be equal to 1 for this question because it is a fixed level. In the short line, you cannot change it. Since the K equal to 1, if I plug this information into the marginal product of labor, I can find out that marginal product of labor should be equal to 5 when the K is equal to 1. Okay, I just use the formula for the marginal product of labor and plug the information that I can derive from the questions for the level of the capital. That's all. It's really easy. What about the B section? Let's assume that everyone needs to make 25 tons of donuts. Okay, so what we need to find out, when again the K is equal to 1, we are going to find out the cost to produce this amount and find out the labor, find out the level of labor. What we know that we have K equal to 1 and we want to produce 25 tons of donuts. It means we have constant level for our production function. Therefore, this amount should be equal to 25. And we know that our capital level is also constant. If you plug 1 into the production function, you can find out that when the 5 times L equal to 25, L should be equal to 5. So it shows the amount of bakers that we need to produce this amount of donuts when K equal to 1. What about the total cost? You can formalize it like that, rent times capital plus wage times L. I know that rent is equal to $500 and K equal to 1. And I know that wage is equal to $400 and I have 5 bakers. Therefore, if you plug this information into the total cost function, I can find out that our total cost should be equal to $2,500. Okay? So that's all for the B section. Let's go on with the C section. Find out the short-run cost function when the K is equal to 1. What we know from the question, we know that our production function is equal to 5 times L. Why I say it like that? Because I know that original version is equal to 5 times K times L, but when the K is equal to 1, it is simplified as a 5 times L. And to derive short-run cost function, we need to use quantity as an input. So I'm not use wage L, R, and K, but I'm going to use quantity as an input. So I need to transfer this function into the another function. What I know that wage and rent information. I plug them into the equation. I know that K should be equal to 1. I also plug this level into the total cost function. And I find out a simpler version of the total cost function. This one. Okay. And from equation 1, we know that if the Q equal to 5 times L, then L should be equal to Q divided by 5. If you plug this amount into the total cost function, this function, I just plug Q times 5 rather than L, okay, this part. Then I can find out that cost function is equal to 80 times Q plus $500, okay? I just do this math and find out this information. Okay, this part is important. If you ask you a short-run cost function, then you need to use quantity as an input. Therefore, you need to transform some information, labor or capital level, into the quantity level, and then you should plug this level into your total cost function. Okay, that's all. Let's go with the D section. Okay, in the D section, it asks us that marginal cost curve from your answer to C. What we know that this is our cost function, and we know that marginal cost curve is equal to partial derivative of cost function with respect to quantity, with respect to production amount. Since this part, you can get zero from this part because it's not something related with the quantity, it's a constant. Therefore, the derivation of it will be zero. And you are going to get 80 from the first term, okay? And then you can argue that marginal cost curve is equal to 80. It is just a line, okay? A straight line. That's all.
Can you open the six questions part A?
Part A, right, of course, this part. Do you have any question about it?
No, I'm just gonna write it. I know, but I have filling. But I'm just filling the gaps.
Okay. I'm going to upload them on the Su course, so you can just take from there also, okay? Okay. You are going to find all solution from the Su course, so you do not have to write now. You can write laterly. That's all also. Let's go with the final question, okay? In the long run, everyone can adjust level of capital, okay? Recognize that in the short run, we are not able to adjust our level of capital because it needs a really high fixed cost. So in the short run, it's not easy to adjust. But in the long run, we can do this. And it asks us that there is a long run cost function. What we know, we need to find out tangent point of isocost and isoquant line, first of all. But we know that slope of isoquant line is equal to marginal rate of technical substitute, which is equal to negative version of marginal product of labor divided by marginal product of capital. And slope of isocost line is equal to negative version of wage divided by rent. You need to know this information for your exam also. It's really important. Just remember that. Okay, I just formalized that. And I know that for the tangency, these should be equal to each other. Okay. What we know that marginal product of labor is equal to 5K from the A section. And if you do the same calculation to find out marginal product of capital, it's going to equal to 5L. So if you want to find out marginal rate of technical substitute, it is equal to negative version of the 5 times K divided by 5 times L, which is equal to minus K divided by L. And I know that wage is equal to 400, rent is equal to 500. Therefore, wage divided by rent should be equal to minus 4 divided by 5. This is the slope of isocost line. This is the slope of isoquant line. This is our production function. And I know this information from the minimization. Okay? It should be tangent. The slope of isoquant and isocost line should be equal to each other. Therefore, I find out that K should be equal to 4 times L divided by 5. If you plug this information into the quantity function, just take this 4 times L divided by 5 and plug this as a K into the production function. Then you can find out that quantity should be equal to 4 times L power 2. And if you leave alone the L, you can find out that L should be equal to quantity powered by 0.5 divided by 2. And then plug this information into the total cost function. Write K as a function of quantity. Since you know the L as a function of quantity, you can plug this information into this part. And then you can take the representation of K as a function of quantity, which is equal to this amount. And you also know that that this part for the L and this part for the K. Just plug this amount into the L in this part and then find out the K as a representation of quantity and then plug this quantity function into this part rather than K. Okay, that's all. If you do this math, you will find out that this amount, and it shows that total cost should be equal to 400 times Q powered by 0.5. So that's all. You find out the long run cost function. I know that Professor solved exactly the same questions, but he find out this information for the fixed level of the quantity, I guess. Okay. He used this information. He equalized quantity as a fixed level of 25, and then solve this problem. Okay. Find out the total cost. I didn't plug. You can plug any of the quantity level here. It's going to give the true total cost function. Total cost level. Okay, that's all. Okay, in this question, you need to remember the isocont and isocost line, their definition. You need to know that you cannot use level of the capital and labor as an input to find out the cost function. You need to transform these levels into the quantity and then use quantity as an input. This part is really important. Okay? You need to remember this. For today, that's all. We solved all problems in the homework. If you have any question about the solution of them, you can ask now, or you can ask later with sending an email. I'm going to solve them also. It's no problem. Okay, that's all for today. Do you have any question about these parts? I think that's fine. I'm going to upload all the documentation, all the documents into the course and drive section also. Thank you for your attendance. Okay.